welcome to this video on quadratic applications. By the end of this video, you should be able to answer questions about real-world quadratic scenarios. So in this scenario, we have a soccer ball that is kicked in the air. The height can be modeled by, and it gives us an equation. Whenever they give you an equation, we're going to graph that. It's going to make our lives much easier. Where h sub t is the height in meters, okay? So that means we're talking about meters up this side here. And t is the time in seconds. So this is seconds down here. It's always important to know your x and y values. So go ahead and pause the video and pull up Desmos and enter that equation into it. All right, so I've entered the equation in. I've scrolled way out. You can see we're out to, 50 here, so we can see the entire graph. Now we're going to plot these three important points from our organizer that we filled out. So our organizer said our important points were our y-intercept, our vertex, and our x-intercept. If the left-hand x-intercept is in negative world, we're going to ignore it, but if it's at the origin, we want to go ahead and use it. So let's take a look at Desmos, and we can see here our y-intercept is at 0, 0. Okay, so we're going to want to plot 0, 0. Okay, and then let's get some other points on here so we can graph them. Our vertex is up here, see, at 5, 50. So I'm going to go over to 5 and up to 50, and there's my vertex. I like to label them too. It's going to make answering some of our questions just a little bit easier. And now let's get our other x-intercept. Now we can use symmetry here. This is our axis of symmetry. This point is 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5. This should be our other x-intercept. We'll just go double check on our graph. And when I go and check the right-hand x-intercept, it is at 10, 0, which is exactly what we ended up graphing here. So I'm going to label that 10, 0. Okay. So I don't have a lot of the points. I'm just going to kind of do this and make it work out. So that's what's happened. The soccer ball. So you had your little soccer player over here, and he kicked the ball. So the ball was on the ground. The ball went up, and then the ball came back down, and it's going to hit the ground right there. Okay, we could go into the table of values and get a lot of these points. We might get some of those. I'm going to write 5, 50 in here. That was our vertex. We could go get more points if we wanted to, but we don't need to. Now, let's do a couple of things here. I want to add in, there's some questions that didn't get asked. I want to add in what is the domain. And then I would like to add in the range. And then we're going to have our interval of increase and our interval of decrease. Okay, so we're going to start with those. Those are a little bit harder, and I want to be able to spend a little bit of time looking at them. So, looking at our organizer, our domain goes from the origin to the right-hand side x-intercept. So I'm going to color code this the same to kind of help us see this. So this is our domain from there to there. Okay. So it is an x value, so look at the x values. The x value here is 0, and the x value there is 10. So we're starting at 0, we're talking about x's, and we're going to 10. It starts at 0 and ends at 10 is what that says. Okay. Now let's look at our range. From our organizer, our range started at the ground and went straight up to the vertex. So we're going to do the same thing. That's our range. Okay, so take a look here. The y value at the ground is 0, so we're starting at 0. We are talking about y values. And then we're going to keep going up until we get to this vertex. And so because we're talking y's, you want to look at the y value of the vertex, which is 50. So there's our range between 0 and 50. What that's telling you is the ball started at the ground and went 50 meters in the air, because we're talking about meters. This tells you the ball traveled a distance of 10 for 10 seconds, because x values are seconds, so it was in the air for 10 seconds is what it's telling us. Now, let's look at our intervals of increase and our intervals of decrease. Increase means where the graph is going up as you go from left to right. So the ball got kicked here and it starts going up right away until it hits the vertex. That's our increase. Okay, intervals of increase, remember, and decrease are x values. So we want to look at the x values that are occurring here. So it starts here where the x value is 0. We are talking about x's. And it goes up and up and up and up until it hits the vertex, and the x value there is 5. So between 0 and 5 seconds, the ball was going up, is what this interval is telling us. Okay, now we want to do the interval of decrease. So the ball hit the vertex height, and that's as high as it went, and then it starts going down from there until it hits the ground. Once it hits the ground, it's done. Okay, so let's take a look. We're still talking about x values. It's at the vertex, so we're talking about it's at 5 because we're talking about x values. And it keeps traveling, 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 and it stops here where x is 10. So between 5 and 10 seconds, the ball is going down, is what this is telling us. All right, that hopefully will help us answer some of these questions that we've got down here. So it seems like a lot of work, but once you get in the habit of understanding where each of these coming from, it's pretty simple. And it really helps if you'll label your points. It helps you identify the starts and stops a lot easier. So our first question here is, what is the soccer ball's maximum height? Okay, so maximum height, if we go back to our organizer, what is the maximum height? That's the y value of the vertex. So the ball is at its highest height right here, which is 50, and we're in meters. So we're going to say 50 meters. After how many seconds does the ball reach its maximum height? Okay, so seconds is an x value. So it reaches its maximum height at the vertex. Well, the x value of the vertex is 5, so it's at 5 seconds. So at 5 seconds after it was kicked, the ball was the highest it's going to get, is what those questions are really asking us about. Now let's look at part D. When does the soccer ball hit the ground? Well, it starts here. It goes up and it comes back down and it hits the ground here. And it asks when. So that happened at 10 seconds. So we're going to write 10 seconds here. See why labeling all this is really helpful. It helps us answer all of these questions. Now, how long is the ball in the air before it reaches its maximum height? Meaning, how long is the ball's height increasing? So it's increasing in this blue area here, because you kicked it and it started going up until it hit the vertex when it started going down. And it says, how long is it in the air before it reaches its maximum height? So it's at 0 seconds here and 5 seconds there. So it's increasing for 5 seconds. And then our last question, after the ball reaches its maximum height, how long does it take for it to hit the ground? How long is the ball's height decreasing? So it starts decreasing here at 5 seconds, and it stops decreasing when it hits the ground at 10 seconds. So from 5 to 10 seconds, that's an elapsed time of 5 seconds. So that's, you can do ourselves a little sketch. We can label all our important points, and it helps us answer all of these questions. I do want to ask one question. Here's another kind of question that shows up. So this says, how long is the ball in the air until it reaches its maximum height? I could also said, how long? No, let's not go. I'm going to ask it differently. Let's ask how high. Yeah, so if I'm asking how high something is, I'm asking about a y value. So how high is the ball at 3 seconds? Okay, this is a real common question. They'll ask you a question that falls somewhere along here. So we're talking about at 3 seconds, how high was the ball? Now remember, we didn't plot all these points, so I don't know that that spot is 100% accurate. So what we're going to do is we're going to have our Desmos that we've already got the equation into, and we're going to go, it says how high is the ball at 3 seconds? 3 seconds is an x value. So let us pull up our table of values and go look where x is 3. It's not on the list, but I'm going to click down here and type in 3. And it tells us the ball was at 42. Well, we know our y values are meters, so it would be at 42 meters. So at 3 seconds after the ball was kicked, the ball was 42 meters in the air. That's a real common question that they can ask you at a particular point along the way. Hopefully that was helpful. Let me know if you have any questions. I'll see you in class.